Or algebra. Hello, welcome to our AP Stats 3.2 notes talking about measures of dispersion. So we're measuring how far the data are spread out. This middle picture here looks like a very compact data set. So we're trying to figure out how far these tails spread out, how wide is our data set. And there are a couple different things we can do. So quick review. What did we talk about yesterday? We talked about our mean, our median, and our mode. So just as a little review, a little reminder, our mode is always and everywhere at the peak. That is your mode of your data set. It is always at the peak every single time. So your mode will always be there. So your mode will always be right at peak. The mean and the median are rarely at the peak. So if you have a skewed data set, your mode will be at the peak, but then your mean and your median will be skewed toward the tail. So if it is a very far left skewed graph, your mean, which will be represented with either x bar or mu, let's say that this is the population. Your mean is going to be skewed toward the tail. And your median is also going to be skewed toward the tail. So your mean is skewed. Your median is going to be skewed a little bit less because your median is more resistant than your mean. So your median is going to be more resistant to change. It's not going to be skewed quite as far as the mean. If you're lucky and you've got a perfectly symmetric graph, everything is going to be right on that peak. Your mean, your median, your mode, it should all be right there in a perfectly symmetrical graph. But in the real world, in a more realistic setting, we're going to have some skewed data. So depending on how skewed your data set is, your mean is going to be skewed much farther to the right. Your median is going to be skewed a little bit less, and your mode is always going to be right on that peak. So your mu, your x bar, your mean is always going to be pulled farther along toward the tail. Your median will be pulled toward the tail a little bit less, and your mode will always be at the peak. So based solely on the mean and median given, let's decide on the shape of the distribution and what measure and center of spread you would use. So in our first example, we've got the mean is 100 and the median is 98. So the mean is farther to the right than the median. The mean is farther to the right. Let's look at our pictures. Here, my mean, mu, is farther to the right than the median. It looks like it's pretty close. So in this case, I would probably just use a bell-shaped or a normal distribution to describe this, but it is definitely slightly skewed to the right, but not much. And if it is approximately normal, I'm going to use the mean or the average to report the center. We're going to use mean. In this second example, my mean is way farther to the left. It is much farther to the left than the median. So this looks like it's going to be skewed left. And if it's skewed, I'm going to use or report the median value, because the median value, as we can see up here, is less likely to get skewed. It is more resistant than the mean. And here, my mean is farther to the right than the median. It is much farther to the right than the median. Kind of looks like this right skewed graph. And if it's skewed, I should report the median as well, because the median is going to be more likely to match the center, the true center of my normal distribution. Okay, so dispersion. Talking about the range, talking about how widely varied my data points are. Dispersion is the degree to which data are spread out. The range is the largest minus the smallest, and variance is the sum of the squared deviations about the population mean divided by the number of observations in the population n. What does that mean? That looks kind of scary. There's a lot going on there. But really, what are we doing? We're taking the sum of, we're going to take what we found, maybe our first data point, and we're going to subtract the mean, whether it's the population or the sample mean. I'm going to square that. And then I'm going to add up data point 2 minus the mean. Squared. And then I'm going to add that to data point 3 minus the mean squared. And I'm going to keep going and then I'll divide that by however many data points I used. So this is how I find the mean. If it's a population mean, then I'm going to use my population mean value of mu. So if it's a population mean, we're using mu. If it were a sample mean, or the sample variance, I would use x bar. So that would be your population variance. If you wanted the sample variance, instead of mu, we're just going to use x bar, because x bar is my sample average. And to find your standard deviation, we're going to find the square root of the variance. So we're going to find our variance and our standard deviation of the following numbers. So first thing I need to find is, what is the average? I need to add these all up. I'm going to find out what is x bar, what is my sample mean. This is 13, 19, 26, 35, 45. 45 divided by 1, 2, 3, 7. So it's going to be 45 divided by 7, which is the same as 6.42, 8, 9, so 6.43. So here's what we're going to do. To find my variance, my sample variance is going to equal my data point 1, which is 3, minus the 6.43 average squared. And then I'll do the next one, 5 minus 6.43 squared. And then I'll do the next one, 5 minus 6.43 squared. And then I'll add 6 minus 6.43 squared. And then I'll add 7 minus 6.43 squared. And then I'll add 9 minus 6.43 squared. And then I'll add 10 minus 6.43 squared. And how many data points did I have? I had 7. So that's how I would calculate the variance. To find the standard deviation, take this number that you get and take the square root. All right, I'm going to edit example 2 here. I want you to find the variance and standard deviation for that data set. And then I'm going to ask you to take a look at 2. And find the variance and the standard deviation of this data set as well. And when you're done with that, please check the answer key that is on the classroom page, and I will see you tomorrow.